accuracy versus precision, very simply. So accuracy and precision can be thought about as a bullseye. So here we have a bullseye. We shoot 3 darts at the bullseye, and what we get is poor accuracy because we didn't hit the bullseye, but good precision because all of our darts went to the same location. So we can have another one here, and we have darts going in. Uh-oh, what just happened here? Okay, this one has poor accuracy and poor precision. Nothing hit the bullseye, and nothing was together at all. So both poor accuracy and poor precision. And finally, boom, boom, boom. This is a dart shark right here, a guy who can hit the bullseye all the time. So this is both good accuracy and good precision. So why are these important? Because we want to make sure that we're measuring properly. So when we have random errors that happen, that reduces the precision. That reduces the ability for us to repeat the measurement over and over again and get the same measurement. Systematic errors reduce accuracy. That's going to reduce how accurately we can measure. So random errors are controlled by the person and the way the person uses instruments. And systemic errors are actually controlled by the instrument. So if an instrument's not reading right, we can correct for that by calibrating it. But if a person's not reading the instrument right because they don't know how to read the instrument right, that's considered a random error, and that's an issue with the person, and it's going to affect how precisely you can measure things, not the accuracy that you can measure things with. So precision, it's about reproducibility. It's about checking and repeating measurements, and poor precision results from poor technique. So that's a person issue. Accuracy is about correctness. How correct is it to the actual value? We check that using a different method. Poor accuracy usually results from a flaw in the procedure that you followed or a problem with the instrument that you have. Usually it's a procedure that you follow. Most of our instruments have been calibrated in some way, shape, or form, or we calibrate them before we use them. Types of errors, systematic errors. Like, for example, we didn't zero the instrument properly, so it didn't read the mass properly. Or we made a chemical with the wrong concentration and we used that instead of using the right concentration. Random errors, so systematic errors are errors that we can't individually control necessarily, that the instrument is creating those errors, but we can correct them in some ways. Random errors are things like the temperature in the room varies wildly. We can't control that. We can't control that one place is hot, one place is cold. The person is not properly trained, so we always try to train you before you go into the lab. Okay, errors in a single direction, that means really high or really low, are usually systematic errors. Errors that can happen in any direction, that can't necessarily be created, that can only be accounted for by statistics. No big deal there. So this is where we've been talking about today in class. We were talking about how we measure something. So if we have this nail here, we can clearly see that we have centimeters, and we have 1 centimeter marks here, 1, 2, 3, 4, 5, 6, and then we have 0.1 centimeter marks in between. This is very much like ruler C on our packet. And so what we can see is that we know the nail is more than 6 centimeters long. But how much more than 6 centimeters? We have to be looking right here. So we know it's 3, and it looks like the tip is going slightly over the 3 mark. So we're going to use significant figures, which we're going to be talking about a little bit more this week too. We're going to report what we know is certain. That means the numbers that we can actually read from the lines are certain. So we know that the 6 is certain. We know that the 3 is certain. Those are certain. The next number, however, is not so certain, and we always add the next digit for uncertainty, and every scientist does this. So we go, all the certain ones, all the ones that have marks are certain, and then any one, the next one after the last one that has a mark is the uncertain mark, and we stop there. We don't go any further. So this instrument can be read to the nearest 0.01 centimeters, and that's really important to know. So if we see this, we see it's 6.35, so it's been magnified a little bit right here, and we see it's past 6.3, and they're estimating that it's about halfway, so it would be 6.35, and that would be the correct measurement. 6 is definitely true. We see the 6th mark. We see the 3rd mark. 6.3 should be the same for everyone. This 5, now this is going to vary slightly. You could have a 4, you could have a 6, maybe even a 3 would work, but the 6 and the 3 should always be the same. The 5 is the one that is the uncertain point. Okay, here we are back at measuring the pin. If we look at the pin, we just looked at the, the nail, and we saw some marks on here. So if we look at the pin in view A here, we see 1 centimeter mark. So we're definitely sure of the 1's place. We definitely know it's past the 2, but not past the 3. So we're definitely going to say a 2. Then we're always also sure of the 10th's place. That's these little marks right here, and we're between the 8th and the 9th mark. So we would definitely say 2.8. So 2.8 would be something that we could say. So we could definitely say for A, we could say 2, we could say 0.8. Those are certain. We can measure those. The next number, however, we do not have a scale for right here. There is no more scale. There are no more marks right here. So we have to guess. To me, it looks about halfway, so I'm going to say 2.85. And that is my answer for A, right? Okay, so that's my answer for A. If I look at the next one, I see something a little different. I see a very similar thing, but this time, right here between the 8th and 9th mark, I see more marks. So this is somewhat like a caliper, what a caliper would look like. We have marks within marks within marks, and we can do that if we can see them. So this is magnifying that, oh, there are marks there. So if we do that, we're definitely sure of the 2. We're definitely sure of the 8 still. But now we have another mark. We see the 5. So we see that the tip of that pin is right there. So we can say 5 is certain. But remember, we will always need 1 past certain. So the 1 past certain, well, it looks to me like it's exactly on the 5. If I think it's exactly on the 5, I write the number 0 because it's exactly on. If I think it's slightly over, I write the number 1. If it's more than slightly over, I write a 2. I look at that, and it's a guess. So a guess implies a range, and the more numbers you list, the smaller the range is. The smaller the range is, okay? The more numbers that you list, the smaller the range is. So, and to be honest with you, this is how we use all our instruments. If we're looking at an alcohol thermometer, we look at this. If we're looking at a graduated cylinder, we have to look at the scale. We have to look at what it's reading. If we don't look at that, then we don't get what we need. Okay? So I'm going to stop right there for today. We're going to look at a little bit more of this later.